The zeroth law talks about defining temperature, and it's the common sense law. You all know how. When something is hot, it's got a higher temperature than when something is cold. But it's important to define that and define something of the thermometer. So what do you know? What's the empirical information that everybody knows? Everybody knows that if you take something which is hot and something which is cold, and you bring them together, make them touch, that heat is going to flow from the cold, from the hot to the cold, right? I make them touch, and heat flows from hot to cold. That's common sense. This is part of your DNA, right? And then the final product is an object, AB, which ends up at a temperature or warmness which is in between the hot and the cold. So this turns out to be warm. Right? You get to a new equilibrium state which is in between what this was and what A and B were. So then how do you know that it's changed temperature or that heat has flowed from A to B? Practically speaking, you need some sort of property that's changing as heat is flowing. For instance, if A were metallic, you could measure the conductivity of A, or the resistivity. And as heat flows out of A into B, the resistivity of A would change. Right? Or you could have something that's colorimetric, that changes color when it's colder. Right? And so you could see the heat flowing as A changes color, or B changes color as heat flows into B. So you need some sort of property, something you can see, something you can measure that tells you that heat has flowed. Now, if you have three objects, if you have A, B, and C, and you bring them together, and A is the hottest, B is the medium one, and C is the coldest. So from hottest to coldest, A, B, C, if you bring them together and make them touch, you know intuitively that heat will not flow like this, right? You know that's not going to happen. You know that what will happen is that heat will flow from A to B, from B to C, and from A to C. That's common sense. You know that, right? And the other way, then the circle will never happen. That would give rise to a perpetual motion machine, breaking of the second law. Can't happen. But that's an empirical observation, that heat flows in this direction. And that's the zeroth law of thermodynamics. It's pretty simple. Right? The zeroth law says that if A and B, it doesn't exactly say that, but it implies this. Right? It says that if A and B are in thermal equilibrium, if these two are in thermal equilibrium, meaning that there's no heat that flows between them, so that's the definition of thermal equilibrium, no heat flows between them. If these two are in thermal equilibrium and these two are in thermal equilibrium, then A and C will also be in thermal equilibrium. But if there's no heat flowing between these two and no heat flowing between these two, then you can't have heat flowing between these two. So if I get rid of these arrows, there's no heat flowing because they're in thermal equilibrium, then I can't have an arrow here. That's what the zeroth law says.